What's up, everyone? Haddern! Welcome again to our channel where we're here to make math easy. Yes, dearie. Alright, so what's on the docket for today, Mr. B? Substantially fixed cucumbers. And how is that done? Well, you see, you take the cucumber, right? That's not a cucumber. Okay there, Mr. Hunt. I know a cucumber when I see one. It really isn't. Well, you take this cucumber here, right? And then you turn it on one side. Okay, well today we're going to teach you about subtracting mixed numbers. Right? And it's a little bit different than what we did before in subtracting fractions. If you didn't see that video, check in the description below to watch that video first. That's really important. Alright, so today we're subtracting mixed numbers. And we're also working on regrouping, which is the hardest thing. You probably run into a problem where you're trying to subtract and you can't. 5 minus 7. Oh, that doesn't work. So we're going to teach you a couple of tricks to make sure that that's super easy. But then you gotta be gentle, just like a small little girly bug. Look for the challenge problem in the lesson and see if you can get it right. Post it in the comments section. All right, and we'll see who's the first one that can do that. And without further ado, let's get started. All right, so today we are going to be working on subtracting mixed numbers. And another thing that we mentioned before is we're going to be doing a lot of regrouping. That's the toughest part of subtraction of mixed numbers. Do you mean to substantially fix cucumbers? No, I don't mean that. We are not doing that. This is a really beautiful train, but that's not what we're going to be doing. We are going to be subtracting mixed numbers. All right, in order to do this, number one thing we need to do is we need to follow the same procedure we used before when subtracting fractions. All right, there's only one thing that's different. All right, and before we get to that, I want to show you this. We have a problem that looks like this. 17 minus 9. Now, whenever subtracting, all right, whenever we add or whatever, we always start in the ones place. We always start in the smallest place we have. All right, so 17 minus 9, when we're subtracting 7 minus 9, we can't do that. So what we do is we regroup. We take a 10, so there's no more 10s there, and we move it here. But a 10 in this place, I know normally we only have one number per place. We're adding a 10 to this 7 here, which so basically becomes 17 in this one place. And we say 17 minus 9 is 8. So in these types of problems, we have to regroup. We have to take a 10 and move it to the ones place. All right, now I want you to keep that in mind as we do mixed numbers. Let's get rid of this. All right, so let's try this mixed number. 6 1/3 minus 3 5/12. Now, if you watched my subtraction of fractions video, the steps are the same, all right? So if you haven't watched it, look at the description below and watch that first. It's gonna be very important that you get those steps, all right? Because I'm gonna be focusing more on what we're gonna be doing when we have to regroup. So the first step when subtracting fractions is we need
a common denominator.
All right, so I look at our two denominators. I have 3 and 12. All right, so they are unlike denominators. All right, so I need them to be common. Now, when we're coming up with a common denominator, we can do it many different ways, but one of the ways that I taught you in the subtraction of fractions video is look at the smaller one and see if you can multiply it by something to get the larger one. So is there something we can multiply 3 by to get 12? And yes, 3 times 4 is 12. Whatever we do to the denominator, we do to the numerator. So let's rewrite these. All right, so we have 6 and We're going to have 12 as our new denominator. And I'm going to write this whole fraction again because we don't have to change it. It already has a denominator of 12. So 3 times 4 is 12. 1 times 4 is 4. So now they have a common denominator, which means we can now subtract. All right, so we always start in the smallest place first. We're going to start with the fractions. All right, so we have 4/12 minus 5/12. Well, that doesn't work, just like we did before. So what we really need to do is we need to regroup. I'm going to take one of these wholes. So I need to borrow one of these wholes. All right, so I'm going to regroup. So this now has become 5, okay? And I'm going to move one of these wholes here, and I'm going to write it as a fraction. Now, to write as a fraction, I look at our denominator, and there's 12 parts. One whole will be 12 out of 12. So I'm going to add that to the one we already have here. So one way to make it a little bit neater is look at our denominator and then add that number to our numerator. So 4 plus 12 is 16. So instead of 4/12, we now have 16/12. So 16/12 minus 5/12. And thus this is an improper fraction because we moved a whole into our fraction. Right? So 16/12 minus 5/12 is 11/12. Now I move to the whole numbers. This is why you will always want to start with the smaller place first. All right, the smallest place you have. So now I have 5 wholes. Okay, erase that little 5. 5 wholes minus 3 wholes is how many wholes? 2 wholes. All right, so we have 2 and 11/12. Now, if you watched the last video, you know what we need to do right after we have subtracted is we need to look to see if we have a simplified fraction.
Simplest form.
So I'm going to look at the smaller of the two numbers, the numerator or the denominator. 11 is definitely smaller. But one thing I already know about it is it's a prime number. The only factors, which are the numbers we use to multiply to get 11, are 1 and 11. So I'm not going to use 1 because I want to see if I can divide both of these numbers by the same number to make them smaller, easier. So I have 11. I know 11 divided by 11 is 1. 12 divided by 11 doesn't quite work. All right, so that means in this problem, this is simplest form, and that's our answer. And that's it. So the only step you're really noticing is different is right here, where we have to borrow, we have to regroup. You've probably heard either one of those terms. We're moving a whole and writing it as a fraction, but we have to add it to what fraction we already have. Okay, so look at the denominator and add that to our numerator. All right, that's the easiest way to think about it. Another way to think about it is we're just adding, since this fraction is out of 12 parts, we're adding 12/12. I don't know what that was, 7/12? All right, 12/12 to this fraction, which when we're adding fractions, our denominators don't change. We just add the numerator. So 4 plus 12 is 16. All right, let's get rid of this one and try a new one. All right, so our next one we're going to try. We are going to do 4 1/5, and we're going to subtract that by 2 1/3. All right, so that's our new problem. So just like before, what's the first step when subtracting fractions or adding fractions? Common denominator. All right, I'm looking at these. I'm trying one of the tricks I taught you. 3 times what is 5? It doesn't quite work, so I can't multiply the smaller of the two denominators by something to get the larger one. Now, can I divide the larger one to get the smaller one? Also, no, that doesn't work. And even if I did come up with a number, our numerator is 1, and I can't divide that. All right, so those ones don't work. So in the subtraction of fractions video, you notice the one way that will always work, no matter which one it is we multiply our two denominators together. So 5 times 3 equals 15. That. All right, it's 15. So I need to rename them. All right, I need to rename these two mixed numbers so that I have equivalent fractions here. Now, I would like to name this one Gugugugugwa, and then this one I feel like it's a she. I feel like it kind of looks like a Samsung. I think I heard that. I don't even know what to say. All right, so let's go along with renaming these fractions. So 3 times what is equal to 15? 3 times 5. All right, so whatever I do to the denominator of this fraction, I do to the numerator of this fraction. 1 times 5. So 1 times 5 is 5. Now I'm going to rewrite my whole number. I'm not changing that. That doesn't get changed when we're renaming our fraction, okay, with a common denominator. So now I'm going to move up here. 5 times what is 15? 5 times 3. So whatever I do to our denominator, I have to do to the numerator. 1 times 3 is 3. And then I carry over our whole numbers. That does not change. So now we have a common denominator. Yes. All right, so now I'm going to subtract starting in the smallest place, which is our fractions. 3/15 minus 5/15. Doesn't work. So I need to regroup. So I'm going to go to the next largest place, which is the ones place. All right, and that's no longer going to be 4, it's going to be 3. And I'm going to write that one whole that I'm regrouping as a fraction. And the easiest way to do it is look at the denominator. That's 15. So that means I'm adding 15/15 to this fraction. Okay, I'm writing one whole as a fraction, 15/15, but I have to add it to what I already have. So 3/15 plus 15/15 is 18/15. All right? So now 18/15 minus 5/15. That equals 13/15. Okay, now I move on to our whole numbers. Now remember, it's no longer 4, which is why I cross it off. Make sure you do that too. I have 3 wholes minus 2 wholes, and that equals 1. All right, we're not done yet. At this point, you're probably sick of me saying this. We need to put in simplest form. All right, we have 13/15. So I look at the smaller of the two numbers, 13, and I think, what are the multiple, or what are the factors of 13? 1 and 13, because 13 is also a prime number. A lot of prime numbers in these. So prime means it only has 2 factors, 2 numbers that can be used to multiply to get that number as a product, 1 and 13. Okay, 1 is always going to be one of those factors for every prime number, because it's actually a factor for every number. All right, so 1, if I divide 13 by 1, I get 13. So I'm not even going to think about that. 13, if I do 13 divided by 13, I get 1, so that works. But now I look at the denominator. 15 divided by 13 equals 1, and doesn't quite work. All right, so that means that this is in simplest form. I can't simplify these numbers anymore. And that's it. All right, so let's erase this and let's try one more. All right, so we got one more. Let's do the fraction 7 3/8, and let's subtract 3 5/6. All right, so just like before, what's step 1? Say it out loud to your computer. Yeah, I know it's gonna be weird, but go ahead, say it to your computer. Yeah, I'm waiting. Yeah, for you. Go ahead. Okay, I heard you. So yes, we need a common denominator. Bingo. So, we can do it many different ways. We You can look at our smaller one. Can I multiply our smaller denominator of the two and multiply it by something to get the bigger one? Nope, that doesn't work. I don't know, 6 times anything equals 8. All right, whole numbers at least. And then I look at my larger one. Is there something I can divide 8 by to get 6? No, no whole number, divide 8 by to get 6. All right, so that means that I could do one of two ways. I could just multiply these two denominators together, or I can come up with the least common denominator, all right? The LCD. Okay, so the LCD, if you don't remember watching this before, it's all talking about what's the least common denominator between these two denominators. Did I hear you say you wanted to get my LCD? No, we didn't. We don't want that. Are you sure? I can get it for you nice and good like? No. I am sure, but yeah, we don't need that. Thank you. Well, I decided to bring it anyway. Here is the LCD. Thanks. We really, really needed that. I'm going to move it off to the side, way over here in the corner, just so it doesn't get written on. All right, so the least common denominator. In order to do this, I look at both of our denominators, 8 and 6, and I'm going to list the multiples for each one of these numbers. I always start with the smaller of the two, and I write the first 4 or 5, sometimes 6. All right, so I'm going to do the first 4 or 5 of these. So 1 6 is 6, but 2 6s is 12, 3 6s is 18. Got to move our LCD. 4 6s is 24. 5 6s is 30. All right, so now we're going to move on to 8. All right, so the best part about this is when you do just one number for like 3, 4, 5, 6 even of those multiples, when you do the big one, most likely you're going to find one that's going to be common. All right, so let's do multiple 8s. All right, multiples of 8. So 1 8 is 8. 2 8s is 16. And so far nothing. All right, 3 8s is 24. Haha, bingo. All right, so there we go. We got a common denominator, all right? And that's the least common denominator. Now, if you follow that procedure of just multiplying our two denominators, which always works, like I told you, you're going to be getting a pretty big number, all right? 8 times 6 is 48. So that's big. So this is going to be a lot better. It's going to be less work. And mathematicians are lazy in the way that they like to do the same process, the least amount of steps. All right, let's make it the most efficient. So I'm going to rewrite so that we have a new denominator of 24, but I need this space right here, so I gotta get rid of it. All right, so 24 is our new denominator. So I'm gonna write it for both. All right, I'm also just gonna write our whole numbers because those aren't changing and we are still subtracting. All right, so in order to come up with our numerators, I look at our denominator, 6. What do I have to multiply 6 by to get our new denominator of 24? 6 times 4. So whatever I do to the denominator, I have to do to the numerator of this fraction. So 5 times 4. 5 times 4 is 20. So then I come up here to this fraction. 8 times what is 24? 8 times 3. So whatever I do to the denominator of this fraction, I do to the numerator of this fraction. So 3 times what is 24? Well, I have to do 3 times 3. So 3 times 3 is 9. And as you've been noticing before, we run into the same issue where we start with subtracting our fractions, but we have 9 24ths minus 20 24ths. All right, and that doesn't work. So that means we need to regroup. Regroup, meaning we need to take away one of the wholes. So now we're left with 6 wholes. And then we need to add a whole as a fraction to what we already have. The way to do it is you look at the denominator and there's 24 parts. So we're going to add 24 24ths. to 9 24ths. Okay? So 24th or 9 24ths, if we just add 24 24ths, our denominator stays the same, but we add 24 plus 9. And 24 plus 9 is 33. So now we have 33 24ths. Okay? All right, instead of this, 33 24ths minus 20 24ths. Denominator stays the same. 33 minus 20. Well, I know the difference is there's 3 minus 0 is 3. And then 3 minus that 2 is 1. So 13 is our difference. And then I go to our whole numbers. 6 minus 3 is 3. All right, so I have an answer of 3 and 13 24ths. But we're not done. We need to simplify.
But in simplest form.
So what are the factors for the smaller of the two numbers? For 13, since it's smaller, I know the factors. The numbers we use to multiply to get 13 is 1 times 13. And again, it's prime. This is a prime number, which means the only factors this has is 1 and itself. 1 and 13. All right, so I'm not going to divide by 1 because it would just give me the same number. So I will divide by 13 and see if it works for both of these numbers. 13 divided by 13 is 1. 24 divided by 13. Now, if you can't do this in your head, you don't notice right off the top of your head, try to just do a little multiplication. 13 times 2. Let's see what that equals. 2 times 3 is 6. 2 times 1 is 2. So 2 groups of 13 is 26, and that's too far. So that means this is in simplest form.
Is that the fork I use for my lunch?
This is my toothbrush. I use it every day to get nice and deep like into them crevices.
I think I know the second.
Maybe my toothbrush will help you feel better. All right, folks. Well, that's all for today. So make sure in the comment section you write down what your favorite smell is. Because I'll be grading which one is the best. And without further ado, that's pretty much the end of our show. So make sure you like and subscribe so you see more of more me. And we'll catch you next time. Smell you later.